Hello everyone, in today's video I will be showing you how to draw orthographic views of given object. Here we will follow the first angle method of projection to draw the views of an object. If you don't have any idea about the first angle method of projection, I have made a separate video on it in detail. I strongly recommend you to watch that video first. The link is provided in the description below. Alright, so let's get started. Let's have a look on a problem statement. Draw the front view of a given object looking in direction X, the side view looking in direction Y, and the top view. Whenever you are solving the problem on orthographic projection, I strongly suggest you to see the direction for front view and side view carefully. In this problem, the direction X is for the front view and Y is for the side view as per the given data. But from Y direction, which side view you would see that you need to identify? I mean, left hand side view or right hand side view. And it's very intuitive. See, X is the initial position of an observer from which observer sees the front view of an object. In order to see from Y direction, observer has to move himself or herself to the left hand side, isn't it? So, it's now very clear that you will see left hand side view from Y direction. So, the three views which you need to draw are front view, left hand side view and top view. Now let's begin to draw. First up, let's draw a faint horizontal line and name it as X and Y. Then draw a vertical line perpendicular to XY. That also should be faint. Now here you can see we have 4 places. And you need to be very careful to allot a right place for each individual view. You know that according to the first angle method of projection, front view comes above XY. And above XY, we have 2 places, one to the right and other to the left. But the correct place to draw front view is the only one. And which is that? I want you to pause this video and think for a second. I hope you got the correct place for front view. It's to the left. Alright, let me tell you why. Dear friends, according to the first angle method of projection, left hand side view comes to the right side of front view. So, to the right side, we need to draw left hand side view. So obviously you need to draw front view to the left. I hope you got it now. Please don't place the views at wrong position. Alright. Before we actually start drawing front view, you need to make sure that you will have enough space from all sides of front view to give dimensions. And to do so, you need to draw a faint parallel line just above XY and at a minimum distance of 20 to 25 mm. Remember, it's a minimum distance. Similarly, draw a vertical line with the same spacing here to the left of previously drawn vertical line. Perfect. Now we are ready to draw the front view. Now, to know how the front view of given object will appear to you, let's imagine that you are standing far away from the object and looking at the object from X direction. Remember, the direction for the front view given is X. So let's observe the object part by part, meaning that initially let's keep focused on this bottom semi-cylinder having a semicircular slot inside it. And imagine how it would appear to you from direction X. So it would appear as a rectangle highlighted in red color, isn't it? And what would be the size of that rectangle? It's 30 by 50 because the outer radius of cylinder is 30 and the length is 50. So let's draw a 30 mm vertical line at a distance of 120 mm from right. Then a 50 mm horizontal line. Then again 30 mm vertical line and finally 50 mm horizontal line. And here we have the front view of a cylinder. Now let's switch a focus to another major part, which is this inverted L-shaped part highlighted in red color, and imagine how it would appear to you from direction X. Now I'm pretty sure you can imagine how this part will appear to you from front. So let's start it by drawing this vertical edge, and the length of this edge is equal to the total height of an object, which is this 50 plus this 20, total 70. So now draw a vertical line of length 70 mm. Then you can see this horizontal edge. So let's draw a horizontal line. Now the next edge which you can see is this vertical one having length of 20 mm. So let's draw it too. Now let's go for this edge having length 50 mm. To show this, draw a horizontal line of length 50 mm here. Then we can see this vertical edge of length 50 mm. Here we can show it by drawing a vertical line, and in the end this bottom edge of length 20 mm. Let's show it with this horizontal line, and done. Now the one last part which we can see from front is this triangular one. In engineering drawing, it has a very specific name, and that's rib. Now we need to show this rib in front view. So as far as this rib is concerned, we can see 3 lines of it. But if you have noticed carefully, the bottommost edge of the rib got overlapped with top edge of the semi-cylinder, and this rightmost edge of the rib got overlapped with this vertical edge of L-shaped part, which we have shown already. So as a matter of fact, we just need to show this inclined line of the rib, and let's show it by connecting these 2 points like this. Perfect. Dear friends, till now we have tried to show the details which we can see from front. Now it's time to look at the object more carefully and look for the things which we can't see from front, like this semicircular slot inside a semi-cylinder. Also the circular hole at the top. These 2 things which we can't see from front, we have to show by using dash thin or dash thick line pattern, which is most popularly known as hidden line pattern. Let's start by showing this semicircular slot having radius 20 mm. Now, sometimes students don't understand, or I can say they are unable to imagine how to show this slot with hidden line. So of course I will tell you what should be your approach to deal with the situation like this. You know that this slot is invisible and you have to show it with hidden line. Now go one more step ahead and figure out which edge of the slot is invisible or hidden. And to figure this out, do a little imagination. just imagine that you are looking at this semi-cylinder from front. But this time, you are going to cut this semi-cylinder exactly from the center, that also top to bottom. Remember, you are doing this just because you want to see this slot which is invisible now. Alright, after you cut this semi-cylinder, remove the front half and observe the remaining rear half. Now you can definitely see the slot. Do you know what we wanted to figure out? We wanted to figure out which edge of the slot is hidden. So this edge of the slot which you see after you cut an object is hidden. So you simply need to locate the exact position of this edge in front view and show it with hidden line. So from the bottom, this edge is available at a distance which is equal to the radius of this inner semicircle or a slot, and the length of the edge is throughout. Apply the same logic. So here let's show this hidden slot by drawing a hidden line at a distance of 20 mm from bottom, because the radius of the slot is 20 mm, like this. Now let's go for this hole at the top. Imagine which edges of this hole are hidden. So here we will have two hidden lines 20 mm apart, because the diameter of the hole is 20 mm. So to show this hole with the hidden line, let's locate the center of the hole first, which is 25 mm from rightmost side. To show the center of hole, let's draw a center line 25 mm away from right, and then draw first hidden line 10 mm away from the center to the left, and the second line 10 mm away from the center to the right. As we can see here, the depth of the hole is limited to the thickness of this slab, which is 20 mm. Perfect. We are done with our front view. Let's now go for drawing a top view. According to the first angle method of projection, the top view comes below the front view. So let's draw a faint projector lines from each and every point from left to right. Then draw a faint parallel line just below XY at a minimum distance of 20 to 25 mm. Perfect. As you have to draw the top view, you need to imagine that you are looking at this given object from top, and then imagine how it appears from top. Let's focus on a single part one by one, which we did while drawing front view. So first focus on the semi-cylinder highlighted in red color. This will appear as a rectangle from top, because when you see this semi-cylinder from top, this left hand side curve edge will appear as a straight line, and the length of that straight line will be equal to the diameter of the semi-cylinder, which is 60 mm. We have this similar curve edge to the right side as well, which will also appear as a straight line. So from top we see this semi-cylinder as a rectangle of a size 60 by 50 mm. Let's draw it by drawing this curve edge first, which will appear as a straight vertical line of length 60 mm, like this. Then this horizontal edge of length 50 mm, and then this curve edge of length 60, and finally the horizontal edge of length 50 mm. And here we have a top view of a semi-cylinder which falls exactly below the front view of the semi-cylinder. Now let's focus on the next part. Here, let's focus on the rib and imagine how this rib will appear from top. When we see this rib from top, we can see these two lines highlighted in red color. And the distance between these two lines will be equal to the thickness of this rib, which is 12 mm. But before we draw the top view of a rib, let's draw a center line showing symmetry of an object. And now let's show the top view of rib by drawing these two horizontal lines which are 12 mm apart. So from the center, 6 mm above one line and 6 mm below second line. Note that the top view of a rib will again fall exactly below the front view of a rib. Alright, now let's shift our focus to the next part, which is this rectangle highlighted in red color. And the size of this rectangle is 60 by 70 mm. We already have shown this 60 mm edge in the top view here. So what we need to draw are only remaining 3 lines. Let's draw them one by one. Again fall exactly below the front view of a rib. Alright, now let's shift our focus to the next part, which is this rectangle highlighted in red color. And the size of this rectangle is 60 by 70 mm. We already have shown this 60 mm edge in the top view here. So what we need to draw are only remaining 3 lines. Let's draw them one by one like this. Now the next thing which we can see is this hole of diameter 20 mm. From top, this hole will appear as a circle. If you take a look at the front view we have prepared, we have shown this hole with the hidden lines here. So the top view of hole will fall exactly below its front view. To draw a circle, we need to locate the center of this hole. So first draw the center line for this hole on the projector of a center line coming from front view. Like this. Now we have the intersection of center lines, which is the center of a hole. With this center and radius 10 mm, draw a circle. Done. Now it's time to look out for the invisible things, like this semicircular slot. As we can't see this slot in top view, we're gonna show it with hidden lines. So again, try to figure out which edges of this semicircular slot are invisible from top. Let's look at this given 3D object. The edges passing through these two corners of the slot are invisible from top. So these two edges we will show with hidden line in top view. And the depth of the slot is 70 mm. So of course the length of the hidden line will also be 70 mm. Also, when you look from top, you can't see the thickness of this vertical slab, which is visible in front view here. Again, you need to figure out, as far as this vertical slab is concerned, which edge of the slab is invisible from top. The edge passing through this corner is invisible. So on the projector coming out from that corner in front view, we will draw a hidden line like this. Perfect. Now we are done with top view. To draw a left hand side view, first we need to draw a line at an angle of 45 degrees from a point of intersection of XY line and a line perpendicular to XY. Then take projectors from each and every point of top view towards this 45-degree line like this, and then transfer this projector straight upward. After this, take the projectors from each and every point of front view towards right. After you take all projectors, take a note, to draw side view, you no longer need to use a ruler for measurement purpose, because this projector is going to help you to give all the measurements. Alright, now to draw left hand side view, let's imagine that you are looking at the object from Y direction. Then imagine how it will appear to you. Again, for ease in imagination, let's focus on a semi-cylinder again and observe it from left hand side. You can see two concentric semicircles highlighted in red color. To draw these two semicircles, we need to know the center point of them. So we have the projector of a center line in center line pattern. So on this center line, we have a center here at the bottom. With this center and radius of 20 mm, draw inner semicircle. Then with the same center, draw another semicircle of radius 30 mm. After this, you can see these two short bottom edges. Let's show them too. Next surface which is clearly visible from side is this, which is highlighted in red color. Easy to show it by drawing these three lines. First line, second one, and the third line. Now let's focus on the rib, the next part. When we look at rib from left hand side, we can see these two edges highlighted in red color. So to show rib in side view, we need to draw two vertical lines which are 12 mm apart. Here you need to look out for the projectors of rib from top view and show rib on the same projectors like this. Done. Till now we have shown everything what we see. Now it's time to look out for the things which we can't see from left hand side. So let's observe the given object and see what we cannot see. So here behind this vertical surface there is a horizontal slab of thickness 20 mm which we can't see. So check the projector of this 20 mm thick slab from front view and show this projector with hidden line here in side view like this. Next, this hole of 20 mm diameter we cannot see. This hole is invisible from front view also. And you know how did we show it in front view? In the same manner, we will show this hole in side view also. So, check the projectors on this hole in top view and draw hidden line on those projectors. The length of these hidden lines will be equal to the depth of the hole, which is 20 mm only. Perfect. Here we are done with our left hand side view also. Final step, I leave it for you. And it's giving dimension to the views. That's all for this video. See you in the next video. Till then, be happy and keep learning.